Welcome to the educational research part of www.happynumbers.org. Today's video is another example of a single case research design, and it is called a multiple probe design. I would suggest, if you have not already, before you view this video, that you look at the video on the multiple baseline design, because the multiple probe design is sort of an adaptation of the multiple baseline design. Let's take a look at our vocabulary. If you have not looked at the AB single case design, you might look at that for a fuller explanation of the vocabulary here. Baseline condition, that's the data that is collected when there is no intervention. And then, of course, the intervention condition. Stability of the data, the sloping trend and level. And the concept of baseline logic, which has to do with the stability of the data points. If the data points are stable in terms of level and trend, and if we're looking at a behavior, we can assume that that behavior has reached its natural level in the environment, and that if there is no intervention, the behavior will stay at that particular level. Internal validity is experimental control. External validity is the ability to generalize, and no one single case design in and of itself can offer a good case for external validity, but we will need many replications so that there will be a preponderance of evidence. In a time-lagged fashion, you need to look at the multiple baseline design to get a good explanation of that. But let's take a look at the multiple probe design. Okay, so we have 4 students, student 1, student 2, student 3, student 4. We're going to use a errorless learning strategy called constant time delay. Look it up, it's a very interesting strategy. Very good for individuals who are classified as learning disabled. Excellent strategy. And we're going to teach each of these students multiplication facts, and we have 10 facts for each student, so this will be the number that they get correct out of 10. That's this axis, and this is the sessions. Let's say the class sessions that we're going to do. So we're going to take baseline data. We take baseline data on all 4 students, and it has stabilized in terms of its level and trend. And now we're going to intervene. Now, we intervene just in tier 1, these are called tiers, and the data moves in a very therapeutic direction, and it reaches criterion. Notice we didn't collect any data here in the other 3 tiers. In multiple baseline, we would have been collecting data here to make sure that it still stayed at baseline level. But in the multiple probe design, now we probe all 4 levels, and we see that this has remained at criterion, this has not moved, this is still at baseline level, this is still at baseline level. So now we can go to intervention 2. Now here, notice we only intervened in tier 2. We did not collect any data in tier 1 or tier 3 or tier 4. And now we collect baseline data again in all the tiers. This stays at criterion. This stayed at criterion. We have not intervened here, and it is back down at baseline level, and we have not intervened here, and this is back down at baseline level. Okay, so now we intervene in tier 3. It moves in a therapeutic direction to criterion. We did not collect any data here, no data here, and no data here. But now we collect baseline data in all the tiers again. This remains at the criterion level. This remains at criterion. This remains at criterion. There has been no intervention in tier 4, and it remains at the initial baseline. And now we intervene at tier 4. It moves in a therapeutic direction. Then we now we collect data. It stays at criterion. This has stayed at criterion, this has stayed at criterion, and this has stayed at criterion. This particular data, the way it looks now, establishes a very strong case for internal validity or experimental control. That it is the constant time delay strategy that is causing the change in the dependent variable the number of multiplication facts that students learn. Now the reason this is called a multiple probe design is because in the intervention, when we intervened in tier 1, we did not collect any data. And then we probed all 4 tiers to see that this data remained at its level, this data did not change, and this data did not change, and this data. Then we intervened in tier 2. We didn't collect any data in the other tiers, but then we probed all 4 tiers. This stayed stable at criterion, this stayed at criterion, no intervention here, so it was at baseline, no intervention here, it was at baseline. Then we intervened at tier 3, but we did not collect any data in the other tiers. It moved in a therapeutic direction. Then we probed all 4. This remained at criterion level, this remained at criterion level, this remained at criterion level. There had been no intervention in tier 4, so it stayed at baseline level. Then we intervened in tier 4. We didn't take any data in the other 3 tiers, and then we probed all 4, and they all stayed at criterion. So the data only moved in a therapeutic direction when we intervened with constant time delay in that tier. Therefore, this design demonstrates very strong experimental control. Now, the advantages, this is very easy to use. The data collection is reduced because you're probing, you're not collecting continuous data in every tier all the time, you're probing. Excellent for classroom use, and it's good for behaviors that are learned or non-reversible. And here is your assignment. You can outline 2 scenarios. This is the typical one that we've been doing. What would be intervention, what would be your dependent variable, and then draw a graph demonstrating multiple probe research design. That indicates good, strong internal validity. You may want to go back and look at this again and how it works. We've intervened there, collected no data in those. Then we probed all of them to see that it stayed stable here, and these remained stable in baseline. Then we intervened in the second tier, collected no data here. Then we probed everybody to see that the stabilized here, this is stable, this remained at baseline, and this remained at baseline because of no intervention. Then we intervened in 3, but did not collect data in the others. Then we probed everyone. This stayed stable at criterion, stable at criterion, stable at criterion. No intervention, so it stayed stable at baseline. Then we intervened in the 4th, no data collected here, and then we probed, and everyone leveled off at criterion. So this establishes very good experimental control. Well, excellent. Thank you very much, and that is a multiple probe design. Actually, that design, as I said, is a variation of a multiple baseline, and it was introduced to reduce somewhat the number of data collection points that were collected. Thank you. See you next time.